In this video, we're going to be using a graphing utility to confirm the given solutions. So here we have negative x minus 1 equals x plus 5 with a solution of x equals 3. So how exactly do we use a graphing utility to solve this? Well, we're going to take our first side right here, and we're going to get that as our first y equals, so negative x minus 1. And we'll take our second side right here. That's going to become our y sub 2, x plus 5. Now we're going to plug these into our graphing calculator and see where they intersect. And we're hoping that they're going to intersect at the number 3, or where x is 3 rather. So the graphing utility that we're going to use here is a TI-84 plus CE. So to do this, we're going to go to our y equals, and in the y1 spot, we're going to plug in negative x minus 1. Again, make sure you hit that negative sign down here for the negative 1, or it won't graph it for you. Then for our y sub 2, we're going to put in our x plus 5, and we're going to hit graph. And we're interested in this point of intersection right here. So we're going to calculate that intersection. So in order to do that, we're going to go to second, trace, which activates our calculate menu, and we want to find option 5, the intersection. So I'm going to choose option 5, and it says what was the first line that we are looking at that intersects. So we make sure at the top here it says y sub 1 equals negative x minus 1. And it says, what's your second line? So here we have our y sub 2 is x plus 5, and we confirm that. And it's like, okay, are you ready for me to guess? And it says guess because when we're solving things graphically, it's an estimate or an approximation. So we're going to hit enter. And it says right there that we have an intersection at negative 3, comma 2. So we're able to verify that this is indeed happening at negative 3. Now I know that for my students, when we're verifying with a graphing utility, I generally have them sketch a picture of the graph that they were given in order to show their work for that verification. But it just needs to be a quick sketch. So we'll go ahead and make that quick sketch. And we need some important points here. For example, our red line is going to be crossing at negative 1, 2, 3, 4, 5, and a positive 1, 2, 3, 4, 5. 1, 2, 3, 4. So we'll have here and here. So that will be our y sub 1. We all use just to make sure that we see that that's which line that went with. So that is our y sub 1 line. And we see that our y sub 2, or the blue line, is at negative 1 and negative 1. We use purple for ours, so negative 1 and negative 1. That's our y sub 2. And we should have an intersection here at negative 3. Let's double check that. Should be at negative 3, comma 2. So our scale is a little bit off. We might need to adjust that. So I'm going to adjust that with my lines here. Let's see here. A little bit closer. And now we have a little bit more accurate representation there. All right, so what about when we have an inequality? How do we do that? Well, let's go ahead and let's pull up our graphing calculator again. And let's clear our space. So we'll go to our y equals and we'll hit clear for those items. We're just going to scoot it over so that we can still see our problem. All right. So same kind of a plan here. We're going to take our y1. Let's use red this time. So this will be our y1. And this will be our y sub 2. And we'll plug those in. So, oh, our y sub 1 was in blue. Maybe I'll adjust that real quick. Okay. So here we have 2x minus 3. And here we have x minus 1. We're going to go ahead and we're going to graph those really quickly. And so what we're looking at here is we're not just looking for the point of intersection. We're looking for where we are less than, right? Where we are less than. So we want to know where our y1 is smaller than our y2. So where is it below, right? Where is it below? So where is it below? So it's below here. That's our area where we see that it is below. So where does that begin? So here we can see that that begins at positive 2, and then it continues as x continues to get smaller and smaller and smaller towards negative infinity. And so there we're going to see how now we've confirmed that this is in fact our solution, that it happens from 2 all the way down to negative infinity, or from negative infinity all the way to the number 2. Now, the reason why we have a parenthesis here and not a bracket is because our symbol right here is strictly less than. We don't want to know when it's going to equal that 2, but be strictly less than that other function. And so now we'll just make a quick sketch of this and be done. Okay. So it's from our green line over. So put a point right here, and then we can know that we're talking about this part of the line. And that's how you confirm the solution using a graphing utility.